Hi, I'm Moise Shamuddin, Assistant Professor of Mathematics, MVSR Engineering College, Hyderabad. In this short lecture, I would like to give a very brief introduction about random variables. I hope you all know that random variables are technical terms used in the study of probability. Probability deals about random experiments. What is a random experiment? An experiment where, well in advance, we know what are all possible outcomes, but we are not sure if we conduct that experiment, what will be outcome in that particular trial. For example, if we toss a coin, we are sure that it will be either head or tail, but not sure which will be the case if we toss a coin. Taking the example one more of a classical die example, if I toss a die, then either it will be showing up as a number 1 or 2 or 3, 4, 5, 6. The set of all possible outcomes we call as sample space. So we are talking about random experiments only. So for that random experiments, we definitely have a sample space. For the case of die, it will be 1, 2, 3, 4, 5, 6. Let's go for another example. I'm taking two different color dice and I'm tossing it. And I'm recording what are the numbers appearing on both the dice. Let me call this is S1. It's a sample space of one die. And I'm taking two different dice. S2 equal to, I'll write some of them, you'll be able to follow the others. 1, 2, so on up to 1, 6. Because the colors are different for two dice, 2 comma 1 makes another sense. That 1 comma 2 is with different colors. Suppose for example green and red. In this case, green is showing 2 and red is showing 1. You can understand, and finally it comes to 6 comma 6. Now these are the sample spaces connected to two different experiments. This is one experiment, this is another experiment. Now there are different notations for expressing these particular sample spaces. We are very interested mathematically in converting all these outcomes to real numbers. Means I want to allot each outcome to a particular fixed real number. How we do that? Mathematically we say like this. In the case of two dice, let us go for a trivial example. Let's not go for that one die. I am talking about S2. We have written, we have seen 1 comma 2, 2 comma 1 also appears, and 6 comma 6. Now by taking the codomain as the set of all possible real numbers, what I am doing is I am taking capital X as sum of two numbers appearing on the dice. With this particular definition, I need to take the sum of these two numbers and it is assigned the number 2. It is assigned the number 3. And also this particular outcome is assigned the number 3. In particular case of last 6 comma 6, it will be 12. Now what are the possible values this X will assume? It will assume any number, integer value between 2 and 12. Okay. Now What is this capital X doing? It is working like a function. It is nothing but a function from S2 to R. Because I am talking about only one particular sample space and one experiment, let me simplify it as S. S is the sample space of that experiment of tossing two dice of different colors, and R is the set of all real numbers. Then, in general, any random variable X is a function from the sample space of that particular random experiment to the set of all real numbers. And you can very easily observe this X is nothing but a function from S to R in this case. Suppose I say I have X2, I call this as X1. Now this X1 is a function. With the same sample space and that same random experiment of tossing two dice with different colors, I have the same sample space 1 comma 2, 2 comma 1, so on up to 6 comma 6. Then I'll write the real numbers here. I'm taking X2 as product. The remaining things are same. That is the numbers appearing on both the dice. In this case, that random variable X2 assumes the value 1, whereas 6 comma 6 assumes the value 36. And you might have noted one thing very nicely here, that it is not going to assume all the values between 1 and 36. For example, 7 is a prime number and this is not assigned to any of this outcome, because 7 is not the product of any two numbers in this list. So there is no pair which is attached with 7. 7 is in the set of real numbers, but it is not assigned with anyone, and hence this particular codomain will be however the set of all real numbers, but that X2 will not assume all the numbers from 1 to 36. Now this particular X1 and X2 are both random variables for the same random experiment of tossing two dice with different colors, and we are defining X1 in a different way and defining X2 in a different way. I can take hundreds of examples with the same experiment. I'll take the sum of the squares on both the numbers. I can take the square of the number appearing on the green die and cube of the number appearing on the red die. So this is nothing but a short introduction of a random variable. We'll see the categories of random variable. Basically there are two categories. One is continuous random variable and one is discrete, and this comes under the case of discrete random variables. We'll see in the next video how will be the classification of random variable into two categories. One is discrete random variable and one is continuous random variable. Thank you.